Welcome to another episode of Crimes Notes. Today's notes you will probably not care for very much because they are word problems, which are none of your favorite. But I'm hoping with the steps that I've given you at the top that you'll be able to figure these out pretty easily. So what we're doing now is that we have kind of come to the end of inequalities, and we need to learn how to apply all that we've learned to actual word problems. So the first step, well, let's go ahead and read one, and then we're going to use the steps that I'm going to give you in order to solve the word problem. So step one, whenever we're reading the problem, is that we need to define the variable. And again, this is what we did before, so these steps should look vaguely familiar to you. And where you're going to find this is you want to figure out what you're looking for. So immediately when you're reading the word problem, you want to go to the very end and kind of figure out, what am I looking for? So for number one, it says Albert earns $3.50 for each hour that he works. If he wants to earn at least $52.50, how many hours must he work? Well, if you look at the very end, it says, how many hours must he work? Well, I'm looking for the number of hours. So we're going to go ahead and define our variable down here as h for hours. And so we're going to use h, and it stands for hours. So we've now defined the variable. Step two means find the answer. What is the overall total, the budget, earning, what you're trying to earn, what's the total price of something, and then this is going to be the right side of the equation. And so once we've found the answer, we need to decide, do we want to be more than that answer, or do we want to be less than that answer? So Albert earns $3.50 for each hour that he works. If he wants to earn at least $52.50, how many hours must he work? Well, the total, or the amount he wants to earn, is $52.50. So that's going to be the right side of my equation. So I would put $52.50. And then I need to decide, do I want to be more, which would be greater than or equal to, or do I want to be less than that, less or less than or equal to? Well, he wants to earn at least that amount. And we really struggle with the words at least, but always think about this kind of as a drinking age. You have to be at least 21 to drink. Well, that means you could be 21 or 22 or 23 or anything. You could be 100. So that means that we have to be more than whatever we're saying. So Albert wants to earn more than $52.50. So we're going to do greater than. And then in these problems, he's okay with earning exactly $52.50. So we're going to add the equal to. And in almost all of these problems, we will have an equal to. So now let's look at step three. Step three says use the rest of the numbers. In other words, we need to look at each of the other numbers that are in the sentences, and then we need to write the equations. So if I go through, I've got $3.50 and I have $52.50. Well, I've already used the $52.50, so the only number I have left is $3.50. And then what I want to do is make sure and see which one of these numbers goes with the variable. Well, the variable is hours. Well, if you look in this sentence, it says $3.50 for each hour. So we know that $3.50 is going to go with our variable. So this is going to be $3.50H. I didn't really leave myself very much room. So then step four is going to be to solve the equation. And then step five is going to be to answer the question. And this is going to be in a sentence format because word problems are always answered in a complete sentence. And remember, you must use an inequality. So more than or less than in the sentence. So you can't say Albert must work such hours. We're going to get an answer that's either more or less depending on how we set up the equation. So let's look at number 1. Again, we've got our equation set up. I am going to go ahead and draw my line. I would do fractions first, but I don't have any. I would distribute, but I don't have parentheses. I don't have any like terms, so I'm just going to go ahead and solve. H is the variable. That means I need to move this 350. Since they're squashed together, that means I need to divide by 350. And I'm going to need a calculator for that. So if I do 50 to 50 divided by 350, I get 15. So here's H greater than or equal to 15. Well, remember, what did H stand for? Hours. And then this was more than, right? We said that that symbol meant more than 15. So the last part, now that I've solved the equation, was to answer the question with a sentence. So Albert must work more than 15 hours. Now, he could work exactly 15 hours, but it's 15 hours or more. So hours must be more than 15 or equal to. Right? Good. And notice I'm boxing the sentence because that is the actual answer. Okay? So on these problems, I'm not just grading the answer. I'm grading that you define the variable. I'm checking your setup. I'm checking your work to get the answer. And then I'm also looking for the sentence. So there's a lot of components for these. So let's go down and look at number 2. Number 2 says the daily production cost for a skate factory cannot be more than $5,400 or $5,400. So again, I'm going to go ahead and highlight that because it's a number. It costs $15, I'm going to go ahead and highlight that, in materials to make each pair of skates. And the daily operating costs are $900. How many pairs of skates can be produced under these circumstances? So the first step is to define the variable. We said to define the variable, we're always going to look at the very last sentence and figure out what we're looking for. Well, it says how many pairs of skates can be produced under these circumstances. I'm wanting to know how many pairs of skates. So you could use P for pairs of skates. You could use S for skates. I don't really care. S kind of looks like a number, so I guess I'll use P for pairs of skates. Okay. Step 2 says to find the answer. So we need to find either the total or the budget or what they're trying to earn. But in this case, and it's kind of easiest if you find the largest number, 15,900 and 5,400, this is kind of the largest number. So in general, this is going to be our budget. It said, or the daily production cost cannot be more than. So remember, step 3 is, well, the end of step 2 says to decide, do I want to be more than this number or less? Well, it says I cannot be more than. So if I cannot be more than, that means I'm aiming to be less than or equal to this number. So the right side of my equation is going to be less than or equal to that $5,400. Well, then step 3 says use all the other numbers that are in the problem to create an equation. But I need to figure out which one is going to go with my variable. Well, my variable is pairs of skates. So if I'm reading, this says it costs 15 in materials to make each pair of skates. So that means the 15 is going to end up going with pairs of skates. And that always means we add. The daily operating costs are $900. So I have 15 per pair of skates. Well, I know pairs of skates is P, so 15P. And then I have plus the 900 in operating costs, which is not going to change. So we don't multiply it by anything. Good. So I've got an equation. So step 4 is to solve the equation. So go ahead and draw the line. Then we need to move this 900. So if it's added, the opposite would be to subtract. So I have 15P less than or equal to, I'll put it over here this time. So 5,400 minus 900 is 4,500. And then I would divide by 15. And I get P is less than or equal to 300. So now I have this solution, but I need to make sure I go back and answer the question. It says how many pairs of skates can be produced under these circumstances. In order to stay under this $5,400, how many pairs of skates can I make? Well, P stands for pairs of skates. So the pairs of skates has to be less than or equal to 300. So we would say we can produce 300 pairs of skates or less. So 300 or less. And then we could put to stay under $5,400. Good. All right, now let's flip it over onto the back. It says a group of 3 friends went to the movies. After paying for their tickets, they had a total of $10 to spend on refreshments. Sodas cost $1.50 each, and a box of popcorn costs $1.75. How many sodas can they buy if they purchase 2 boxes of popcorn? So let's go ahead and figure out our numbers. I've got $10 to spend. We have sodas that are costing $1.50. And I've got popcorn that is costing $1.75. And then I do have these words, a group of 3 friends. So the 3 could be important, but we'll look at it. And then we also have down here 2 boxes of popcorn. So we're going to go ahead and kind of highlight everything. And then it says, how many sodas can they buy if they purchase 2 boxes of popcorn? Well, our first step is always to define the variable. And to define the variable, we always read that sentence. And it wants to know how many sodas. So I know I'm looking for S, which is sodas. But we actually have another variable because it still talks about if they purchase 2 boxes of popcorn. So I do actually have a second variable here. I've got popcorn. So now we're supposed to look for the answer. So I need a budget or a total or an earnings. Well, if you look, here's our total. It says we have a total of $10 to spend. Well, if I only have $10 to spend, can I spend more than $10? No. So that means the right side of the equation is going to have to be less than or equal to that $10. I can't go over 10. I don't have any more money. So then what am I trying to buy with that $10? Well, I'm trying to buy sodas and popcorn. So does this 3 friends have anything to do with the equation? No, not really. They're there, but this is all about me and the money that I have to spend on them. So sodas are $1.50. Well, we said sodas is S. So that means I'm going to do $1.50 per soda. So I put an S with the $1.50. There's that word and again, so I know I'm adding. And then it says $1.75 for popcorn. So I'm going to put $1.75p. Now here's the problem. Now we have 2 variables that we're trying to solve for, but we can't solve for 2 variables at the same time. But if I go down to one of the other things I highlighted, notice it says that I purchased 2 boxes of popcorn. That means that I can actually replace P with 2. So if I rewrite this, I have $1.50 plus 175 times 2, because I know that I bought 2 boxes of popcorn. Good. So from there, I'm going to have you guys set this one up and try to solve it. Good. So I'm running shy of time on this video, so I'm going to go down and set up number 5 for you, and then number 4 will actually be on a separate video, so make sure that you go back and watch that second video. So let's look at number 5. On an interstate highway, the maximum speed is 70 miles per hour, and the minimum speed is 45 miles per hour. If X represents speed, then write an inequality to express this condition. Notice it doesn't say anything about solving. It doesn't say, it just says write an inequality. So we've got a max speed of 70 miles per hour and a minimum speed of 45 miles per hour, and X is representing speed. So defining the variable here is going to be very easy. X is what they want me to use to stand for speed. And then to write an inequality means that I need to write something that shows that the maximum speed is 70. Well, if the max speed is 70, I can't go above that. So I have to be less than or equal to 70. But then there's a minimum speed of 45. So that means that I have to be more than 45. So that means that my speed, X, has to be between 45 and 70 miles an hour. So this is a compound inequality that represents the statement that is in that sentence. There's nothing to solve. There's not really a sentence to write. We just define the variable and write an inequality. Good. So remember to look for that second video to go over number 4.